Hi kids, it's Mrs. Fravel again. How are you? Good, good. Hey, today I'm going to talk about our last concept in our ecology unit. I'm going to talk about how energy flows through an ecosystem. And then you know what, you guys? That's our last thing. We're done. We're done for the year. So this is the last time you have to see me or listen to me. Whoa, hey! I hope you had a good year. I'm sorry it ended so weirdly, and I miss you guys still. I still miss you. It's been 2 months. Still miss you. So next year, pop in and see me. Hopefully, we're back in the building next year. As long as everybody's good and stays away from everybody else, we'll be fine, right? All right, let's get to it. Please make sure that you are filling in the note guide as I go through this. That's going to be your only assignment with this concept. Then I'm going to post a quiz that you'll need to take. That'll be the test for the unit, and then boom, we're done. I'll have more instructions for you next week about how to make sure that you finish out the year with the grade that you want, okay? So let's go. Here we go. We're going to talk about how energy moves through ecosystems and how ecosystems are structured in terms of how many living things an ecosystem can support. Okay? We talked a little bit about that with carrying capacity, and I'm going to show you how different organisms' carrying capacities influence and compare to each other. Okay, first of all, let's review some things you should know these words already from middle school. You know these, right? Just write them down again so you remember them. Okay, really quickly. Autotrophs and producers, those are two different words for the same type of organism. Those are organisms that make their own food from the sun or from a chemical energy source. These are plants and algae and some bacteria in the deep sea. They store that energy as glucose in their tissues. Heterotrophs or consumers are animals. These are animals and fungi. These are organisms that have to eat other things in order to acquire energy. So they get that glucose from the tissues in producers. Okay. There are different kinds of heterotrophs, different kinds of consumers. We have herbivores. Those are animals that eat plants. Carnivores eat animals. Omnivores eat both plants and animals. Scavengers are animals that eat dead animals. And scavengers and decomposers tend to get confused. So I'm going to go just real quick. Scavengers are animals that eat dead animals. So these are on like a big macro level. If something dies, the first thing that happens is that their body lays down on the ground or in the water, and they are scavenged first. These are animals eating their dead tissue, things like vultures, crows. In the ocean, there are sharks that are scavengers and jawless fish that are scavengers. They just take care of that dead tissue. And then on the micro level, the next thing that happens to dead tissue is there are decomposers, and they get their energy from dissolving the nutrients left in the tissues that weren't scavenged. Okay? They return those nutrients to the environment to be taken up by the autotroph in the environment. Okay? All right, let's talk about food chains. You guys kind of know what food chains are, right? A food chain is the simplest path that energy takes through an environment. Generally, when you think of a food chain, you might think of who eats whom, which isn't wrong, but we're going to narrow that down and look at how the food chain is really how energy flows through the environment. The fancy word for energy is trophism. Trophic levels are the levels represented in an energy flow in a food chain and food web. So each thing that eats a thing is a different trophic level, and I'll show you what that means in just a sec. So here's a very basic food chain. Of course, we have the producers absorbing the energy from the sun, and the sun is the source for all energy everywhere in every ecosystem on the planet, except for a couple of them. Take my marine biology class to find out what that is. And that energy is passed through the ecosystem one level at a time. So each of these represent a trophic or an energy level. until we get to the decomposers that decompose all of the dead things and return that nutrient to the grass producers. Okay. Let's talk about the trophic levels specifically. I'll go up there. Okay. The first trophic level, these are the primary producers. On land, those are plants. In water, these are algae and chemosynthetic bacteria. These are the ones that make the food. Okay. Second trophic level are the primary consumers. These are the herbivores that eat the plants. Okay. These are things like grasshoppers, rabbits, plankton, cows, horses, all of those big plant eaters and little plant eaters as well. And they are right here in the graphic of an energy pyramid. Okay. The third and higher trophic levels, those are all of the carnivores and omnivores and apex predators in a ecological energy or trophic pyramid. So they fall in the secondary consumer level and tertiary consumer level. Sometimes you'll see quaternary energy levels or consumers, and those are just fancy words for second, third, and fourth. Okay. Okay. Food chains look really easy, right? You've seen this before where we have a thing that eats a thing, that eats a thing, that ate a thing, right? So when we look at food chains, what I want you to make sure that you understand is when you see the arrows in a food chain or a food web, the arrows don't really mean who eats whom. The arrows represent the direction of energy flow through the trophic structure. So in this first one, we have this lichen, the producer that made the glucose from sun. That energy from the lichen is transferred into the slug that eats the lichen, and then the energy from the slug is transferred into the toad that eats the slug, and the energy from that toad is then transferred into the snake that eats the toad. And that snake, the energy that it gets, originated all the way back here with the producer. Same in each of these other food chains as well. Okay? So in a food web, what that means is in a natural ecosystem, it is really, really rare for any given organism to only be eaten by one other kind of organism or only eat one other kind of organism. In general, most organisms eat a variety of foods. There are some specialists, but usually what an ecosystem actually looks like are crossing over and intersecting food chains to become a food web. And again, the arrows, when you follow them, that is the direction the energy is flowing through the ecosystem, okay? So when we look at this one, we start with the grass, the producer, right? And its energy is going to flow to each of the organisms that eat it. So its energy flows to the rabbit, its energy flows to the deer, and its energy flows to the grasshopper, right? And if we look at this rabbit, for instance, rabbits are eaten by several different predators, carnivores. So any given rabbit's energy can flow to the foxes that eat it. It can flow to the owls that eat it, and then even the hawks that eat rabbits as well. Rabbits are like the McDonald's of an ecosystem, just FYI. Okay? So again, energy flow, trophic energy flow is what the arrows represent. Make sure you write that down. Did you get it? You can pause me anytime, okay? Ecological pyramids. So we want to look at how we quantify, how we count how many organisms at each level an ecosystem will support. And we look at that in three different ways. Okay? We can look at how energy flows through an ecosystem and how many organisms the energy supports at each trophic level. We look at the biomass, and we look at the just the counted numbers of organisms. And I'm going to go through each one of those. Okay? So we'll start with energy. Energy pyramids compare how the energy used by producers is passed through the food chain, the food web. And what we look at with energy are these numbers here, kilocalories. Kilocalories are just a measure of how much energy is contained in the tissues of all of the organisms at that trophic level. So we start down here at the producers. If we have 10,000 kilocalories of producer in an organism, that 10,000 kilocalories is enough to support 1,000 kilocalories worth of primary consumers. Did you see that? 10,000 can only support 1,000. Only 10% of energy moves between trophic levels, is passed on to the next trophic level. 90% of all the energy in tissues is lost to the environment. Poof, okay? So only 10%, make sure you write that down, make sure you know that only 10% of energy at each tier is passed on to the next level, okay? Same thing. Okay, so that was an energy pyramid. Biomass pyramids are a little different, but we still see the same trend. An ecosystem can only support so many animals at each level. And that also, when we just look at how much organisms weigh total in an environment, that also follows that same 10% rule. So if we have 1,000 kilograms of plants, that 1,000 kilograms in an environment will support 100 kilos of herbivores. Those 100 kilos of herbivores will support 10 kilos of primary carnivores and 1 kilo of top carnivores. So again, 10% rule as you go up. That's how many organisms will be supported in an ecosystem. I gotta turn off my phone volume. Okay. We also look at the same trend in just pure numbers. If you go out in your yard, why not, and just start counting things at each level, at each trophic level in the food web, we get this same 10% number. If we have 100,000 leaves on a tree, let's say, those 100,000 leaves will support 10,000 caterpillars. 10,000 caterpillars only supports 100 small birds, and those 100 small birds will support one apex predator. In this case, it's a hawk. Okay? So that's how we get the numbers of organisms that we see in an ecosystem. All right, so the opposite, however, which is not good, is seen in an ecological pyramid called the biomagnification or bioaccumulation pyramid. Now, this is not a natural pyramid. This happens because humans like to put poisons into the ecosystems. We either fertilize or we poison the things that we don't want there anymore. We use pesticides to kill insects. We use herbicides and fertilizers to kill or feed the plants that we use, right? That has an opposite trend as you go up the trophic level, as you go up the food chain. All of the toxins in an environment actually stay in the tissues at each level in every organism. So if we have producers that absorb from water 1,000 units of a poison, in this case, DDT, back in the 1970s, this was discovered, 60s. That 1,000 units, as each level is eaten, by the time we get up to the apex predator, there is 10 million units concentrated in that apex predator's tissues. And that's generally enough to kill them, which is why we are also seeing far fewer apex predators than should be there. No, okay. Still the 10% rule, just opposite and bad. Okay. All right. I'm going to run out of time, so I'm going to end this. I'm going to be done talking at you for once. Forever. Okay. I hope you have a good summer. Go take your quiz. Make sure you submit the notes for this, and I will send out more instructions for next week on how to finish out the year. Miss you guys. stay safe, stay home, keep 6 feet between you and people that are not living in your home, wear a mask, and I hope to see you next year. Come say hi.